In this lesson, we will discuss how an aircraft is controlled around its normal axis. We will also discuss the control position indicator, which is used to keep pilots informed of the position of their aircraft's flight controls. Rotation around the normal axis is yawing and is controlled by the rudder, which is normally fitted to the trailing edge of the tail fin. The rudder is required to maintain directional control with asymmetric power, to correct for crosswinds on takeoff and landing, to correct for adverse yaw, to recover from a spin, and, on a single-engine aircraft, to correct for changes in propeller torque. The rudder is a flap-type control and is controlled from the cockpit by the pilot's feet moving the rudder pedals. Pushing forward on the right rudder pedal moves the rudder to the right, generating an aerodynamic force, causing the nose of the aircraft to yaw to the right. Pushing on the left pedal causes the opposite to happen, and the nose of the aircraft will yaw to the left. With a simple control system, full rudder pedal movement will provide full rudder deflection. With high-speed multi-engine aircraft, it is necessary to have large rudder deflections available at low speed to allow the aircraft to be controlled in the event of engine failure. However, when flying at high speed, full rudder deflection would cause excessive loads on the structure. To prevent this occurrence, a gear change system, known as a rudder ratio changer, may be incorporated into the rudder control system. This may be a single gear change, which gives a smaller rudder deflection for full pedal movement above a certain speed, or a progressive gear change, which gives a decreasing rudder deflection with full pedal movement as speed increases. This graph depicts the operation of a typical ratio changer. You can see that full rudder is available up until 160 knots. The travel then reduces progressively until at 380 knots, only approximately 3 degrees of travel is available with full pedal deflection. You now know how the aircraft is controlled about its 3 axes. To keep the pilots informed of what the primary flight controls are doing, their positions are displayed on an indicator on the flight deck. There are a number of different systems used for this. Displayed here are the systems used on the Boeing 747 and on Airbus aircraft. The older electromechanical indicator for the 747 is quite simple and self-explanatory, but rather limited in what it can display. The electronic indication on the Airbus Electronic Centralized Aircraft Monitor, ECAM, on the other hand, is able to display a wealth of information. The letters beside the individual surface indicators show the status of the hydraulic systems operating the surface. They are normally green, but change to amber in the case of a failure. In this graphic, the blue hydraulic system has failed. That is the end of the lesson. You now know that control in yaw is achieved using the rudder. Also remember that modern airliners have some type of rudder ratio change mechanism to reduce the amount of rudder travel at high aircraft speed.